Imagine you are running a toy factory. Making a toy requires a strict two-step process. First, a heavy machine stamps out the basic blank shape in plastic. You have to do this step first because you cannot paint or customize a toy that doesn't physically exist yet. Python works the exact same way. When you create a new piece of data, what programmers call an object, Python runs it through this same two-step factory line. This diagram shows two factory signs representing special instructions called dunder methods. That is just short for double underscore, because their names have two underscores on each side. The two instructions we care about are dunder new and dunder init. Dunder new runs the molding machine, physically stamping out the blank object. Then dunder init takes over at the painting station to add your custom details. To understand how Python builds things behind the scenes, we separate the act of bringing an object into existence from the act of setting up its details. The dunder new method handles that very first phase. It has one single responsibility: the physical creation of the empty object. This code window sets up our molding machine. We declare a custom object and define the dunder new instruction. Then, a specific line commands the machinery to stamp out the blank shape, calling the main system to create our empty toy. There is an absolute rule. The molding machine must actively hand the newly created object down the assembly line, or the process crashes. To do this, we add a return statement in our code, guaranteeing the blank toy moves forward. The molding machine is completely blind to the final toy's design. Its only measure of success is whether the blank shape exists and keeps moving. Our blank toy now arrives at the second station, where dunder init steps in. Init is short for initialize, a programmer's way of saying set up or customize. This painting station cannot build anything from scratch. It relies entirely on receiving that pre-made blank object from the molding machine. Back at our code diagram, we expand the window to define the initialization step. We accept the blank toy and a custom value. Then we write a line of code taking that value, painting it directly onto the object. Notice how this station operates differently. Because the object is already safely on the conveyor belt, this setup step doesn't require a return statement. It applies the paint and finishes the job. The init method focuses entirely on giving a blank object its unique identity and state once it has safely entered the system. When you are writing a program, you don't usually see all this machinery. You type a single line of code to ask for a customized object. This diagram shows what happens next. That one simple command secretly triggers the entire two-step factory sequence in strict order behind the scenes. Here's a comparison table reviewing the rules. Dunder new is our molder. It creates the object, runs first, and returns the result. Dunder init is our painter. It customizes the object, runs second, and doesn't return anything. In everyday programming, you will use the init method constantly to set up your data. You rarely need to alter the new method unless you are dealing with highly advanced scenarios. Understanding how Python builds its data means recognizing this hidden partnership. Every new object you create is the result of a coordinated two-part relay race between creation and initialization.